So today what we're going to be doing is we're going to be talking about quadratic equations and factoring. Now, when we're talking about factoring, we know what that means. We do common factoring and we do decomposition and we also do just regular factoring. But there's a reason for this. When we actually take a look at this expression, ax squared plus bx plus c, this could be equal to anything. So in mathematics, we call this y equals ax plus b a quadratic equation, not a quadratic expression. This is a quadratic equation. Now, the reason why it's called a quadratic equation is, yep, you guessed it, because we have an equal sign. Basically, what you need to realize is that if we choose or input any value of x, we get a y back. And that's why we call it a quadratic equation, because we're using it, we're making whatever that is equal to y. When we do quadratic factoring, quadratic equation factoring, we're specifically doing the following. We're simply letting y equal 0 in this equation that we talked about before, this quadratic equation. And so we get something that looks like this. 0 equals ax squared plus bx plus c. Or ax squared plus bx plus c equals 0, because those two equations are pretty much equivalent. The key concept of today's lesson is that a quadratic equation, this thing up here, contains a linear term that can often solve by setting it equal to 0. The y value is our linear term. We set it equal to 0 and then we factor. And now, after we factor, the right or the left side of this equation, this part or this part, depending on where your 0 is, basically what you end up having is this thing called two brackets. Those two brackets we called linear equations. Now those linear equations allow us to take use of this thing called the zero product property. So the zero product property is referring to this. If mn equals 0, then we have either one of the two possibilities happening, or three. We got either m is 0 or n is 0, or both of those things are equal to 0. So if I have a bracket that factors to xm plus n and x plus n equals 0, then either this half, the first half, is equal to 0, or the second half is equal to 0, or both of those brackets are equal to 0. Now, let's go through some examples. Now, let me give you some extra terms here. Anytime you hear the word solve, we're talking about a solution. Solution means find an x. We'll discuss what that means in our lesson for the day. So what I want you to do, make sure you copy the rest of this note, and then we'll see how all of this applies. Okay, now enough of that. Let's move on to our problem. Here's the example. We're going to solve the following quadratic equations. Now remember what I told you. Solving means to find an x. Now in this specific case, when you look at this equation, you're actually trying to find an x that makes this entire equation, the left side of the equation, equal 0. And the way we're going to do this is using the zero product property. by factoring the left side of this equation, we're going to see something miraculous. Okay, so if I take my finger and cover equals 0 here, what you would do is if I said factor, you'd know what you'd have to do. You'd just basically common factor. You'd look at the GCD of 3x squared plus 6x, and you know that it's going to be 3x. Because 6 and 3 are both divisible by 3, and the lowest power of x in that left side is x. So now imagine, just like before, we used to divide what we see there by 3x. So now 3x squared divided by 3x is just going to be x, and plus 6x divided by 3x is just going to be plus 2. Now, let's go and take a look at our zero product equation and idea that we had before. It said if I have two numbers or two brackets, mn, which equals 0, then either the first bracket or numbers are equal to 0, or the second bracket or numbers are equal to 0, or both of them are equal to 0. So in this case, imagine we're going to take a look at what this or this is. So essentially we have either 3x equals 0, the first factor, the GCF, and the other stuff that was in our bracket equaling 0. And now all we have to do is imagine that we're just going to solve each of these equations individually to find out what our solutions are, or zeros are. For 3x equals 0, we have to get rid of the 3. So what we're going to do is we're going to divide both sides by 3 to get x equals 0. Or, now, for the second equation, x plus 2 equals 0, what we're going to do is we're going to move this plus 2 to the other side, just like before when we were solving equations. So we have x is equal to 0 minus 2, which simplifies to x is equal to negative 2. So basically you say 2. The solution is x equals 0 or x equals negative 2. So the solution is x equals 0 or x is negative 2. And what that really means is this. If I plugged in x equals 0 into the original equation, then the left side of this equation would be 0. If I plugged x equals negative 2 into this equation, it would mean the right side of the left side of this equation would also equal to 0, which would mean the left and right side are equal, so therefore it is true. So let's just quickly do a check just to show you. You don't have to do this, but a lot of you have never seen this before. So let's check to see if our answer is right. So check. X equals 0. So what we do is we basically just say, well, we take a look at the left side of the equation, we write it down. The left side of the equation is equal to 3x squared plus 6x. Now let's plug x equals 0 into there. 0 squared plus 6 times 0. Well, this is 0, and then this is 0, so the overall is 0. The left side equals 0. The right side of our equation, which is right here, is also equal 0. And you'd say this upside down 3 dots, since the left side equals the right side, therefore x equals 0 is a solution. So these are kinds of problems that we've seen that you'll eventually have to do. So what I want you to do, if ever I ask you to check, you just go and check each of your solutions. You check the first and the second, and you'd show something exactly like this. Now we'll move on to our next problem. Now we'll do the same problem again. So we have on the left side something that looks like this, and we have to find our solution. So every time we see something that looks like a quadratic on the left side of an equation, we must factor. Now imagine we cover up this and get rid of this 0. We would normally say, okay, we'd look at this problem. This is a simple factoring problem. So we would say, okay, we need a number that adds to 8 and timeses to 12. You guessed it. The answer is 6 and 2. So the left side of the equation just turns into 2 brackets if we use our simple factoring method. So this ends up being just x plus 6 and x plus 2 equals 0. So now that I have that happening, the next part of our problem is we have to say 1. Either x plus 6 is equal to 0 using our 0 property, our 0 product property, or x plus 2 equals 0. So now all we do is just solve for x. In this case, the first one, x plus 6, we move the 6 to the other side, and we end up with x equals 0 minus 6. And our final answer is x is equal to negative 6. And similarly, x plus 2 is equal to 0 turns into x is equal to negative 2. And notice I'm putting a box around here, and I'm putting an or here. And I'm also putting our second step to our problem. So you'd say the solution is x equals negative 6 or x equals negative 2. I'm not going to ask you to go and do a check unless you absolutely have to. Just refer to this note in order to understand how to do a solution. Check. So now for the next problem, we're going to realize that on the left side of the equation we have a difficult factoring polynomial. So let's do that. So we're going to go and factor the left side using our difficult rules. Now we must have a number that adds to negative 5 but timeses to negative 6. Now the reason why this is negative 6 is because the a value here is 2 and the c value here is negative 3. So when we have our difficult trinomials, we use this property a times c and put it in our box for our times. Now here's what we should have on the left side of the equation right away, because negative 6 and 1 are the numbers we need. So applying our decomposition rules, we get the following. For the left side, we get this. And in order to finish the problem, we just have to add equals 0 to it. Now, we're going to follow the same rules we did before for decomposition on the left side. So on the left side, we should get the following. So we end up with this. And then at the end, we must say this is all equal to 0. Of decomposition, we're going to get our factored values to be this equation. And then at the end, you must say equals 0. And now we're near the end of our problem. So now we must factor out x minus 3 because it's common to both terms. And then we have 2x plus 1 as our final answer equals 0. Now all that's left to do is to do our either and our solution statements. So we have either x minus 3 equals 0 or 2x plus 1 equals 0. Now, For the first part, we're going to solve for x minus 3. So we're going to go and take the minus 3 and move it to the other side. So now we're going to get x equals 0 minus 3, which ends up being x is equal to minus 3. I'm just going to put a box around this. Or our last statement, 2x plus 1 equals 0. So I want to isolate x, the 2x, so I'm going to move my 1 to the other side, the end of that 0. So now we're going to get 2x equals 0 minus 1. For these last few problems, we have to rearrange our equations. So now what we're going to do is we're going to take a look at x squared equals 7x minus 15. So the key idea, move everything to the left side. When you get better at this, you could move all your information to the right side of the equation. So in this case, I look at this problem and notice I have 7x plus 15 on the wrong side. So I'm actually going to move everything to the left side. And I'm going to move it in such a way that I have 0 is equal to, well, so if I moved the 7x over and the 15x and the 15 over, the 7x becomes negative 7x, and the 15 becomes negative 15, and our 2x is just plus 2x squared. Now, what we're going to do on the left side is we're going to rearrange everything into something we understand. Remember, all our equations must look like ax squared plus bx plus c, right? So we're going to rearrange the left side to look something similar to what this looks like. So now we're going to have, well, 2x squared minus 7x minus 15 equals 0. Now, based on that problem, we're going to have a problem that is a difficult factoring polynomial. So this is a number that adds to negative 7 and timeses to negative 30. The two numbers we need are negative 10 and 3. We'll use that for the left side decomposition of the equation. Decomposition ends up being 2x squared minus 10x plus 3x minus 15 is equal to 0. Putting our stuff in brackets, we're going to get 2x squared minus 10x plus 3x minus 15, and we must put equals 0 to the left of all of that. Now we'll do our common factoring for each pair of numbers. So the first one becomes 2x, and we end up with x minus 5. And the second bracket is going to be 3x, pulled out, ends up being x minus 5 again, equals 0. So now all we have to do is pull out x minus 5 for both of these parts. And then we're left with 2x plus 3. Let's make one small correction. This part here must not be 3x. It must be just 3. And all of that's equal to 0. So for the first stage of our solution, we have to say either x minus 5 equals 0 or 2x plus 3 equals 0. Now for this one here on our left side, x minus 5 equals 0 really means x is equal to plus 5. Let's see if you can figure out what that means. And now inside the second bracket, we have 2x plus 3 is equal to 0. So let's move our 3 to the other side. And we get 2x is isolated, and we get 0 minus 3. So that means 2x is equal to minus 3. To get 2x by itself, we divide both sides by 2. And we get x is equal to negative 3 over 2. Now, the second stage of this problem is to say the solution is x equals 5 or x equals negative 3 over 2. So what, remember, that means? If I plug in x is 5 into the original equation, the left side will equal the right side. That's all you need to know. As for our final problem, requires us to use some mad skills. So let's use some sophisticated moves here. Let's go and take the 3y, y plus 2, and we're going to move the entire quantity from the left side over to the right side. So now, instead of having our 0 on the left, on the right, now we're going to have it on the left. So we're going to have 2y squared minus 4. And now, instead of having 3y plus 3y bracket y plus 2, we have minus 3y, y plus 2. Now, the trick to this problem is recognizing that we have a difference of squares in one of the collection of terms. This first bracket, I'm actually going to do that right now by showing you what we're going to do. We're going to break this up into y plus 2 and y minus 2, because y squared minus 4 is a difference of squares. And then I leave the rest of the work that we just pulled over alone. Now, all we have to do is we have to find things that are common in each collection. The thing that's common in each collection is, well, y plus 2. So let's go and bring y plus 2 to the front of a collection of terms. So I'm going to say y plus 2. So imagine we divide y plus 2 out of all of this. What's left over? I'm going to use a special bracket, a square bracket, to distinguish something that we might have to do. We might have to do some simplification in the next bracket. So when we go and pull out a y plus 2, we end up having left over 2 and then y minus 2. And then we also have, well, 3y and y, if we divide both of those by y plus 2, we end up with minus 3y. So now all we have to do is our last step. I'm just going to bring down my 0, and I have y plus 2, and I have my square brackets again. And if we simplify this bracket by chasing waterfalls, we're going to get 2y minus 4 minus 3y. If we simplify that bracket on the right side, we're going to get the following. 0 is equal to y plus 2, and we're left with 2y minus 3y is negative y, and minus 4. So I'm going to say, therefore, the solutions are, well, the last trick I'm going to tell you is this. You can change this to opposite world. Basically what you're going to do is you're just going to flip the signs of what's inside here. You look at y plus 2. The only way that y plus 2 could equal 0 is if y was equal to negative 2. So I'm going to say y is equal to negative 2. For the second bracket, I look at minus y plus 4. Sorry, minus y minus 4. The only way minus y minus 4 could equal 0 is if y was equal to 4. And we're done. So literally, that's 1 and 2 being brought together in one step. So I look at that bracket as opposite world. If I see a plus 2, I say y is negative 2. If I see something inside my bracket that makes the whole thing 0, that is what I let y equal. Your homework is these questions that you see at the bottom of the page. Page 14, 1 to 3. 5 to 7 ACE for each. And then I want you to do page 14, number 8, and 10 to 12. Good luck.